A large cube is formed from ice. A light ray is incident from a vacuum at an angle of 46 degrees to the normal on one surface of the cube. The light ray is parallel to the plane, one side of the cube. The angle of refraction inside the cube is 33 degrees. Calculate the speed of light inside the cube. Okay. What I did, by the way, I got this wrong because I just calculated the index of refraction. There's two ways to do this. One is to just use Snell's law, N1 sine theta 1, which, by the way, is not in the data packet as such, but it's how I do all of these problems, right? And then just remember that what n is what the speed of light divided by the velocity in that medium, right? I think this is right because the velocity gets less, and so speed of light divided by a number that's smaller than the speed of light gives you a number that's bigger than 1, okay? So you could do those two steps, but you can also, if you look at the diffraction and stuff, there's also this formula that's just terrible. Okay, so N1 over N2. This is what it really looks like in the data packet. This is the first part, and obviously if you cross multiply that, you get Snell's laws. I feel God intended it. Okay, and then you get V2 over V1, right? So this is what you could do, right? Is you could, vacuum. You could go, this is 1 and this is 2, right? And you could say this is theta 1 is 46, theta 2 is 33, V1 is the speed of light, so 3.00 times 10 to the 8th. V2 is what you're trying to solve for, okay? And the answer is between 2 and 2.5 times 10 to the 8th meters per second, okay? So whichever way you want to do it, okay? Then it says, show that no light emerges from side AB, okay? So this guy is going to go across, strike at some angle here. Okay, so that angle that it strikes at, we got to figure that out, right? And what's going on there is that angle is going to be too big. It's bigger than the critical angle, right? So the first thing is to figure out the critical angle. Find theta c. And the way, how do we do that? We go N1 sine of the critical angle equals N2 sine of 90 degrees, right? Okay, which basically, this is just 1, okay? But this is my cop-out way. I don't want to remember a new separate formula for the critical angle. So remember what we're going to do is we're going to make this refracted angle, we're going to pretend like it's 90 degrees because that's what's going on, right? So this would be what? So now 1 is inside the ice and 2 is outside the ice, right? Okay, and so figure out what that critical angle is, right? And then figure out what this angle is in there, okay? Now, how do you do that? Simple geometry. Make a triangle, right? This is 90 degrees, that's 33 degrees. You can show that angle is bigger than the critical angle. I used this, I had to dredge this up. The sum of the angles is, right, 180 equals 33 plus 90 plus theta 1 in this theta, I guess I'll call it theta 1. Call this guy theta 1. Okay, so find that angle, show that it's bigger than the critical angle, right? So sketch on the diagram the subsequent path of the light ray. Well, remember, when it doesn't get out, it reflects, okay? So it's going to reflect, it's going to strike this face. Then you have to decide when it strikes this face, right? Okay, so this thing's, I'm trying to draw a very careful picture, right? So it's going to reflect off of this face. Okay, that angle that you figured out here is going to be the same as this angle here. Okay, these angles. So once you figure out this, whatever that angle is there, right? Okay, this will be the same angle, and then you can do the same thing here with this. That's 90 degrees. That angle, you know what that is because it's congruent with that, and you can find this angle. If that angle is less than the critical angle, then it will escape from the ice cube. If it's, then the picture gets more complicated. Okay, I'll give you a clue. It does escape from this side. Okay, that's kind of fun. Okay, I even drew a picture and labeled the diagram. And then if you figure that out, then maybe think about going back to that practice problem with the isosceles prism that I put on the practice problems. Okay. All right.